Hi, everyone, and welcome to our webinar on how to train large language models with your own data. I'm Brandon Welch, Director of Revenue Operations at Nerdery. Thanks for joining us. Nerdery is a digital solutions provider delivering digital consulting, custom software development, cloud development, and data and AI solutions. The world of artificial intelligence is rapidly evolving, and large language models, LLMs, are at the forefront of this revolution. These powerful tools can process and generate massive amounts of text data, making them ideal for tasks like personalized customer interactions, automated tasks, data analysis, and insights. But how do you leverage the power of LLMs for your own business? In today's webinar, we'll be demystifying LLMs and showing you how to train your own custom model, tailored to your specific needs. I'm excited to introduce our speaker today, Justin Ritchie.
Hi, everyone. Thank you so much for joining us. Obviously, it's kind of hard to have a slide. I'll introduce myself, and we're going to have a really great chat today. Just kind of my journey and kind of getting into Gen AI, and really what's been passionate is having been a developer for a long time. Really, as we made dashboards, there were so many times that people would say, just send me the nuggets, just send me the most important things. And a long time ago, learning that, hey, how could we automate this with natural language? How do we build into some of those insights? And that kind of what got me on my journey through this about 10 years ago, and then leading into the boom that we've had in the last couple of years. Really want to help demystify this, as Brandon said, but then also being able to build on this and how you can leverage this in your organization as well. So kind of our agenda today is we're, obviously going to be able to talk about the modern LLM stack. It's really evolving much more into software engineering principles and how that's guiding. And then we're going to have some really great demo content as well. So we're going to walk through a data set example on GCP, but really the core of it is running LLMs on your own database. So we're going to introduce concepts like RAG and lane chain, and like, how do you get started in that as well? And then we'll be able to talk about expanding that functionality. A lot of us were at Google Next a couple weeks ago, and there was a flurry of new services and products that were announced during that time, which was very exciting. But the great news is that whatever cloud platform there is, there's a lot of contribution to the open source community as well. So we'll talk about some of those services that fit into that, and then we'll make sure to leave some time for Q&A, and Brandon will be our moderator for that once we get to that section. So just a big quick plug before we lose people in case anyone has to hop off. This webinar is meant to be a 101 course of really how to get started and really where to drive that. This next one that we'll have on June 18th is really how to build AI agents. So that's going to be going a lot deeper into the lang chain side. We'll be able to talk about multimodal generative models and how that parses into that, whether it's chatbots or being able to discord back with the user itself. So we'll go much deeper into that, and then we'll talk a little bit about how that leads into it. But just know that's going to be our second step of this kind of journey, and hopefully you can make it with us on that date as well. And as always, we'll have the recording too. So before we get it, just kind of level set as a primer here, generative AI, really, what is that? As we think about more classical machine learning, you're looking at more discriminative methods. That's when you're predicting a label of something. So if you look at data, we train that model to begin to understand mortgage default, not default. Will someone make it there on time? What is the value of that prediction? That's really taking training data and providing that into an output label. So that gets to the discriminative methods. As we look at generative AI modeling, it's a lot more probabilistic. It's using joint probability. Transformers have really helped that industry move forward as well. But it's essentially taking unstructured content, sometimes structured data, as we'll talk about in a second, and then as learning patterns from that, and then being able to drive that into an output and synthesizing new content as well. I kind of want to also talk about this. I'm a big fan of Jeffrey Moore. So Crossing the Chasm is one of my favorite business books, really looking at this from an innovators, early adopters, early majority, late majority, and laggards. These gray boxes, as you see, this is kind of where I'm seeing a lot of that same content on both respective sides that are really providing a lot of noise. Is that a lot of organizations are like, where do I get started? I see a lot of content on how do I prompt ChatGPT or how do I prompt Gemini to do this for my data? But then on the other side, there's this like extreme advanced examples of like build an LLM from scratch. And there's not really a lot of content that's coming out. Really kind of in that the early majority side is that's kind of really what we want to cater this talk with today is just like how do you get a realistic practical example of where to get started. Also, a call out here is that the easiest part is the technology. And I understand this is a technical webinar, but just really want to help level set is like without understanding legal, PR, compliance, and stakeholder involvement, it's going to be really hard to get this off the ground. And also understanding that, prompt engineering is definitely a new aspect that companies are being able to adopt. But also that guided prompt needs training. And what training comes change management. And a lot of organizations haven't done that work, especially from a data governance perspective. And that's a really important aspect to drive this further to get better adoption in the organization. Really looking at engaging subject matter experts. At the end of the day, we hear a lot of opportunities of people saying, we have 5,000 PDFs, we have a call center. We want to be able to drive that content in an insightful way of helping our business users to access that data better than rather than just doing a search in just a Windows folder, being able to do that as well. And then fourth is manual testing doesn't cut it. Adding automated evaluations into testing. So this goes anywhere from model weight analysis into quality engineering, as well as some of the aspects of like, is this actually giving us the results that we want? So I'm sure some people have heard of the term hallucinations. How do we limit that in these types of development environments? But it's a really important aspect is that UAT is not just manual testing of that. And kind of along this lines is I'm sure a lot of people have seen new model just announced and it's 5x better than the previous model. And while that some might be true, those evaluation metrics are very subjective. And it's a little bit of marketing fluff, but then also being able to understand it's better to have something that's catered to your specific use case that's most accurate versus something that might be optimized for another evaluation criteria itself. So we're going to kind of get into the LLM stack and talk about some terms, and then we'll kind of get into the demo right after this. So, really, if you were to start from basic one, what do you want to be able to get into? Really, prompting LLM is the easiest way to go. You have pros or lower AI skills, RAG, which we'll talk about in a second, being able to augment data freshness. It's also the lowest cost as well. Cons is there's some of the precision is lost. There's potential security concerns if you're not careful. Next is being able to tune an LLM. So there's a lot of different ways that is threaded, but it's really specialized for your domain specific. Really, there's two camps right now of customizing LLMs. One is being able to drive an LLM with fine tuning for your business or using RAG more for AI application architectures as well. Tuning an LLM, there's a couple different ways, as I mentioned, but the biggest issue is that the tuning can degrade over time with data loss, as well as you have to host it yourself, which is a challenge. And then full blown train your own custom LLM. Like we're talking millions of dollars to do this right. I think the most recent model that was trained from what cost $180 to be able to train that just from I think it was like 800 billion parameters to have that run. But also it does have the highest accuracy, but you need to have a team. You need to be able to have GPUs and TPUs on demand and then really deep AI skills as well. I'm a big analogy fan. So if I were to think about these three as a camp, is from prompting an LLM, it's kind of like renting an apartment. You can see if you like it, but also you can leave as well. If you're going to tune an LLM, it might be building a custom home with a builder. Some of the layouts are going to be somewhat static. You can move a kitchen on one side or another. You can make your garage a foot or two deeper. But it's more or less kind of cookie cutter that way that it's the same, but you get to pick the finishes and finishings of how that operates, like carpet and cabinets and things like that. In training a custom LLM, it's like building a custom home on a remote island. You have to have everything ferried into there, very expensive, but obviously when you're done with it, it's very grand and wonderful theoretically. Before we get into RAG and talking about this, as I mentioned in the last slide, there's really fine tuning versus RAG is typically the two paths that companies go. If you want to be able to tune an LLM for your specific ways, there's a couple of ways that you take the weights themselves and adjust that to your specific business case. It's a really big training job and very expensive. The other issue that people don't talk about is you actually have to host it once it's done as well. So obviously it's not just the cost of training, it's the API calls and the token costs that happens. There are some other methods. One just example is parameter efficient tuning methods. That's be able to not disrupt the core model, and you actually can adjust the custom data and the weights that be able to interact that. There's a lot of content in this space right now that's coming up of like, how do we not adjust Gemini Pro, obviously, just because that's such a great model, but being able to leverage some of the parameter efficient tuning methods. And there's a variety of others as well. So I just called that one up as an example. Really kind of the meat and potatoes is this slide. So this is saying, okay, we're going to go stage one, renting the apartment. We want to be able to understand what prompting an LLM would be. How do we drive data integration and customization? Being able to take that of saying we're going beyond just an interface of loading something to get something out. It's really more out of the box. Stage two is really the core of this conversation, is we're being able to leverage tools like BigQuery, structured and unstructured and relational data sets that we'll show in a second, but being able to refine the inputs. And we'll talk about what that means as well. As you get past stage two, you get into more of the stage three, which is really deployment of RAG, which stands for retrieval augmented generation. And really what that does is it says, okay, well, we have a core set of an LLM that's trained and that data is mostly fixed. How do we augment that information with our own information for our best practicality for our business? But then it also gives us the ability of locking down those results as well. And we'll talk about that later in the data security section. From a stage four perspective, that's when you're full out building AI agent and AI application. Being able to combine RAG and LangChain allows you to build customer support tools, interactive decision aids. This is really where there's a lot of excitement in the industry right now, is being able to build these AI apps, and kind of the new buzzword that's coming out is AI agents as well. So like I said, we're really kind of between stage two and stage three for this conversation. For our June webinar, we'll be between stage three and stage four. Kind of going into RAG a little bit deeper. So we provided this visual to kind of help contextualize. So as you think on the left side of your screen, you have a database, documents, you're being able to tokenize that. Another term is called chunking, basically how that data gets loaded into a vector database potentially. Then you have the LLM. But then the user interfaces with the LLM as a prompt. The prompt then goes through a variety of embeddings to pull that data out and then decides which one is best for that user, and actually go through a hierarchy method as well. But as you see the two cyclical circles, that's really the gray area of how does this interact with your actual data. And that's really where we want to have you take away from this presentation today, is it's that overlapping Venn diagram that's the most important. And there's a lot of different architectures of how you support that. And we'll provide some recommendations for that as well. As we build on this a little bit more from the last slide is, thinking of this from a 1, 2, 3 method. So you have your source data, you put it into an embedding model. We're going to assume a vector database for this slide, but you also can do this with a relational database, and we'll talk through that in our demo. So basically you will load that in a database and it will store that through embeddings in an index. And then step one is a app or a user parses a natural language question, like what store has sold the most. And then there's semantic search. So it basically finds that highest value that could begin to parse that, and it looks for similarity scores. And there's a lot of different ways that similarity is defined, whether it's cosine similarity, Euclidean distance, dot matrix as well, are all methods of that. And then that actually prompts the LLM to say, we found the most relevant information, and then it essentially overlaps that with the LLM. And then that's passed into an application, and then it's retrieved for the user. As an example on embeddings, just kind of want to walk through an example, is we have a retail data set that we'll show, but really want to think about population versus commute time. I find this fascinating because the larger the city, you would assume that it is a longer commute time, but that's not always the case. So if you think about Indianapolis and Vegas, roughly, they are 24 minutes of their commute time. Vegas has 656,000, Indianapolis has 880,000 people. San Francisco has 808, so kind of similar. I was shocked to hear that Indianapolis is similar size to that. DC is 671. Obviously, the larger DC proper, you can make the arguments a lot larger than that, but this is just in that downtown area. But those have much higher commutes. And, you look at that, you're like, that makes sense. Those are much larger metropolitan areas. It's harder to get into. People don't live in the city as much, so there's commuting times there as well. But then you think about LA, and, LA is historically, people talk about the traffic in that city, Philadelphia, but then New York's in its own camp, right? So, 8.2 million people in that larger area with a 36-minute commute time. Now, where embeddings comes in is that it looks through, this is a two-dimensional space, and it essentially calculates those values of similarity. So it says these are bucketed, and that's why we showed those yellow circles earlier of these are essentially 4 different related buckets. So then when a user would say, show me the best commute time for New York from Bronx or from Long Island or Coney Island, and being able to pull that, it would know that this is related to that embedding value. So as we look at building on that, it's more than just a two-dimensional graph. Obviously, it's really hard for humans to imagine what n dimensions would look like, but there are instances where you'll have 100 plus dimensions that create different embedding scores. And what this does is it puts unstructured data into a vector database. And really the sweet spot here is that what those embeddings are, those essentially are values that you can calculate. And through GCP, you actually can use embedding scores and actually store those as JSON, both for quality control as well as auditing methods as well. That then goes into an index. So what that index does is it basically helps it find that. Otherwise, it'd be very, very hard just to go vector database or relational database to build on that with an embedding value itself. So the index is really kind of that gatekeeper, really that key that gets in that. And then more classical data warehousing, Lakehouse, it's very similar to how indexes are made for just relational tables as well. It essentially helps that data. So with relational tables, partition data typically is how that gets split off. Embeddings is typically with the vector databases themselves. Kind of spicy take here is we want to talk about why projects will fail. And just kind of before we get into some of the demos, like there's a lot of aspects here that makes these projects not successful. And we want to give you some tools to help you take away from this as well. Not understanding cost ramifications for LLM API calls. So for example, if you were to deploy a chatbot for an individual user that is spread across 10,000 different views and 10,000 different users, that's immensely expensive to have it fully customized for each user. You can't do that. A good example is Spotify, that they've actually optimized how the individual song recommendations are deployed to the user actually at the device level, be able to provide that as well. So that's a really fascinating architecture, but there's a lot of different research that's coming around that. Really data scientists, there's this misconception right now, we need to hire more data scientists, but I would actually make the argument on this webinar that like you need to have a lot more cloud ML or software engineers because knowing myself as more of that traditional data scientist that's, kind of come through the industry. And before that was just BI analysts is the issue with that is a lot of the things that LLM does automates a lot what data scientists do, but software engineers, machine learning engineers, and cloud engineers and data engineers for that matter really are helping with the infrastructure because it's not as much about the math and the algorithms as much as how you integrate that to best user experience with that as well. This industry is moving incredibly fast, but not understanding DevOps tools. When we think about distributed applications, there's an open source tool called Ray that is really prominent right now in the industry that I highly recommend you checking out. But then also looking at things like containers and Kubernetes and Cloud Run is like, how do these services kick off? How do they provide the RAG? How do they provide the information retrieval for these users at application time, at runtime? It becomes a lot more of a software engineering DevOps perspective than it does a data scientist perspective. Fourth is not creating ROI metrics from project conception. If we do this, this is 100% what we should expect from that. And where I've seen teams get laid off, especially in the last couple of years, is that a lot of those teams that would get let go is that they didn't have ROI tied to what they were doing. And doing technology for technology's sake is really hard, especially in this industry, in this market right now. And I think a lot of people know that industry from a tech perspective, we have to have everything tied to a bottom line right now. Domain-specific knowledge limitations leads to poor results. So if you're not able to tie into those domain experts of actually taking that analysis, that institutional knowledge, if it doesn't translate into an LLM insightfully, it could create issues in how that's used, but then also lack of adoption as well. We've talked about a lot. There's been a lot of buzzwords that we've been going through, but we really want to kind of re-encapsulate this section with kind of a glossary of terms. So, as we think about tokens, Tokens are essentially used as the lifeline of a lot of these aspects. It's used for both from payment and consumption, as well as like how large something is. So tokens are kind of the red blood cells of sorts, if you want to think about that through. Chunking is basically segmenting text or data into smaller manageable pieces that an embedding model could pick up. A vector database index is indexing mechanisms for fast retrieval in a vector database. A vector database embedding is really stored as vectors, be able to provide that similarity search perspective. An AI model from a RAG perspective is using that from retrieving relevant data, both from a user-specific data, as well as being able to provide the most insightful way in an application. And then LangChain is really that tool model building that's used with the LLMs. Think about React and building front ends that users can use for that as well. With that, we'll kind of get into some of the core of the demo content. First, what we're going to show is a data canvas, which is a brand new tool that GCP announced. So I'll share my screen. There we go. So really want to give a primer on what this data set is. So this is taken from kaggle.com just to make sure we're not showing anyone's data and sensitivity, obviously. But really we have store number, date. So this data is a little bit dated just intentionally. We're looking at sales data. We're looking at a holiday flag. So if there's a holiday, July 4th, Christmas, Thanksgiving, whatnot. But then also looking at temperature, looking at things like fuel prices, the consumer price index and unemployment. So this retail store example is being able to show that and being able to say, what are some of the methods of how we want to predict sales, or how do we want to predict where demand's going to be across these sales in the future? It's not just looking at what it was from a previous sales perspective, but what are some of the macroeconomic ramifications of this? So holiday flags is a big one. We were in a workshop a couple of weeks ago, as if there's a football game as well as a holiday that are plus or minus 2 days, completely gridlock traffic, which might affect retail sales or it might help it. But then also looking at fuel prices, and obviously we talk a lot about Fed rates right now in the economy. That's a component that does influence buyer behavior as well. So if you want to think about it from being able to drive that data, is like you'll say, well, we don't have enough people that know SQL that could drive this tool. So being able to go in the bottom right here is you actually can go new SQL query. And as you see, this is very Gemini centric, but you could say prompt a SQL query to find total items for this. So you could say, what are the top 10 stores by sales? Make sure I got that correct. And then what it will do is it will generate a SQL query for you automatically, which is fantastic. So I'm going to close this window just so it's a little bit easier to see. And then if I go a little bit larger, so it essentially pulled, you select store, sum sales, total sales, seems pretty basic. And then you're limiting by 10 and descending that. Makes perfect sense, right? But then if you run that, what it does is it generates the results in a table. You're like, okay, that's pretty cool, but like, how do I build on this? How do I share this insight with users, right? So this is a table you could export directly to CSVs. And for the people on the call that we know that make dashboards all the time, it's, making dashboards for the sole reason of exporting to CSV, it's incredibly challenging. And you have to make a lot of different use cases and a lot of different ways to kind of work through that. So obviously that's really easy to do that as well. You can explore the data yourself with Sheets, Looker Studio. You could put it into a Python notebook if you really wanted to, but being able to encapsulate natural language search directly with SQL and providing that into Looker Studio, kind of giving the ability to quote unquote Google your own data is pretty powerful. I'm just going to hit the visualize aspect right here. And then if we just do create a bar chart, so I'll put a value of a bar chart, and really what I want to show here is really cool. So if we go a little bit farther up, being able to just copy and paste these natural language, these are kind of the nuggets, right? So like I talked about is like what got me into this industry was I would make a dashboard. The VP or the SVP that I'd be working with would say, I don't have time to go through a dashboard. I got a meet in 11 with my boss. Can you send me the 5 or 6 nuggets in that dashboard that I should be presenting to my boss on where we should go from a perspective? And being able to say store 20 has the highest sales, contributing 11%. Store number 1 is the lowest sales. And, looking at that perspective is really powerful to give that natural language side as well. As we start thinking about kind of bringing this back within the environment of GCP, having BigQuery Studio being able to drive that is immensely powerful, that you actually can join multiple data sets as well. So we're going to take this demo a step further, and I actually want to show you some of this code of how we can actually build custom front ends to this as well. And again, this is not RAG. This is more maybe RAG light, if you want to think of it that way. I would actually say that it's not, but this is just a really easy way to kind of get started. So querying that exact same BigQuery data, we want to be able to power Gemini with using a Gemini API key that allows us to natural language search our own data. Basically what we just did, but we can actually add a custom front end as well. So if we think about being able to write several functions, we provided that into a SQLite perspective to be able to load the data. We're providing a parameter that's pulling in the Gemini response data. We're essentially loading our prompt engineering. And what the prompt engineering is doing here is you're basically saying you're an expert in writing SQL. Here's some examples. Obviously, this is very explicit in how this is designed. This is somewhat intentional, knowing just for the scope of this webinar. When you start leveraging RAG, that's where RAG will be able to find, it's not just average sales. It's like, what about cosine similarity for other values and other metrics that you care about? And that's really when you start building on this with RAG, as well as LangChain, that you can kind of get past that. But then essentially what we do is we do some of the configuration values. We're looking at some of the padding, and you'll see in a second what this will look like. But a big aspect is you have to really have the DevOps in place. So, just having basic Docker files and containerizing these applications is really what allows you to start building some of these custom front end. But as you can see, it's pretty easy to automate that from our perspective as well. And then from a BigQuery file, you're essentially just pulling in the JSON value. And then we store our environmental variables and, having Google Password Manager and secret key protection to make sure your data is not leaked that way. So let's go back to the front end that we've been talking about. So you could say, so this is the front end that I just showed everyone. So you could say, get answers from your own data. And I could say, what store has sold the most? And if you enter that, so this was made with Streamlit. So this was made just to be kind of a basic example. But you could say total sales across all date regions is for this. And then you could say, what value, what store is being able to do that as well. So you could say what store has the highest average sales. Store 20 had average sales of 2.1 million. And obviously being able to structure this into a natural language retrieval is pretty important. Otherwise, before it would just return a JSON field, and it's a little bit harder for a user to kind of copy paste that. All right, so this is all fine and dandy. We showed data canvas. We showed what a kind of a very, very basic front end of this would look like. The reason why this is great is this allows you to get deeper with that. And the big aspect is like really impress upon this webinar is it's about the evolution of this. It's not about going in and building something for 9 months. These tools are changing by literally the week by week, and having something that can be able to do that as well is going to be very important. So I'll share my screen again. So let's talk about expanding that functionality. So as we look about expanding the functionality, data protection, that's a huge one. Right. So if you could say, hi, my name's Justin, my social security number is this, and my date of birth is that. Probably a big no-no, if you would imagine. Being able to protect that. GCP does offer a tool called sensitive data protection, SDP. Essentially, what it would do is that if a user prompted that application that I just showed you, or even in data canvas, that it would say there is 150 different data elements that are really driving that aspect, to be able to block that as well, just to make sure that that data is not transferred. Another question you guys might have is, like you said, okay, well, you showed the RAG architecture and there was that overlap. Is my data being transferred to the LLM itself? And the answer is no, but there's a very important call out. As these applications build more and more on each other, it's going to be really important to understand identity access management, being able to understand API gateways to secure what data is being transferred. It's really going to be in that data encryption aspect. So data at rest and data in transit. So ingress versus egress. That data encryption, if it's not secured when it passes into an LLM via the vector database embeddings, you could expose that data to an internet-based endpoint, and that could be a large issue. Having GCP autologs is going to be really vital to tracking that activity to understand what data is being transferred. But when you have a relational data store like we showed in BigQuery, and if you were to overlay that with RAG, that data doesn't pass into the LLM. So the data from the LLM is not ingesting that LLM data. That data is looking at cosine similarity versus RAG to pull in the most important thing. And then it essentially goes through a hierarchy perspective to show this has the most value for this user. And then it provides the LLM response that sits on top of that. And, looking at how would we architect an application at scale, really breaking this out into two components. One is the serving subsystem and then an embedding subsystem. So the embedding is really where the data exists. That's really what the data processing pipeline, a vector database, data stores, embedding services really happen. And then if you look at the serving subsystem, that's the audit, that's the safety features, that's the SDP that we mentioned in the last slide. That's building your own custom front ends with LangChain. That's looking at your inference servers. This is really where things like Ray become very important and being able to retrieve that information, but then how do you display that information to provide the best user experience? And then kind of following a more microservices approach, this is going to give you the ability of upgrading components of this. So rather than saying copy paste a vector database and having to rebuild everything, you can look at more of an architecture based perspective. And there's ways that you can leverage serverless applications, whether it's Cloud Run, being able to look at that as well. There's lots of ways you can get started with this without everything being homebrew as well. Where does LangChain fit in all this? And, I love this slide because you look at Kubernetes, roughly 2015, really helping with distributed application development and being able to containerize apps. It's had a steady up and to the right. Well, obviously Google and GCP is a large contributor to that community. LangChain kind of came out of nowhere. And where I'm a big fan of LangChain, having, seen the CEO talk a couple times, I like to think of it as really a complete set of interoperable and interchangeable building blocks. And really what that gives you is the ability to connect to private data sources, connect to private APIs, being able to provide that customization and that control with really that runtime backed in. Being able to understand where are the abilities to leverage, how do we connect to more data? How do we pull in more data? We talked about BigQuery and how do we look at vector databases, but how do you connect relational or vector database stores with unstructured data? We have 5,000 PDFs in our organization. How do we drive that to merge all of that into an environment? And LangChain can really help orchestrate those components with being able to leverage that into an application. One aspect of BigQuery is BigQuery really is, it's a relational database tool. You could do lakehouse architectures, but currently in public beta, we have a vector index and vector search features that are coming out. So being able to swap between a vector data store as well as BigQuery itself, that's going to be really important to be able to drive that forward. But then having that feature fully supported in BigQuery and just that environment are going to be very critical for that as well. As we start thinking about how LangChain can begin to interject that, it's really critical to see like having vector support in a tool like BigQuery is going to be very critical for that method as well. And then also how does RAG fit into all this? And looking at the metadata, looking at the vector indexes, being able to provide that search query itself, and being able to have that show from an embedding perspective. It's going to be really important to think about the prompting side of it and how does that begin to show that from that optimization. So really, where's RAG going to go? And where RAG is really heading right now is that TLDR, it's not going anywhere anytime soon, especially as you start thinking about where user access is going to be able to show how do we retrieve our information, but then how do we also overlay that from a user perspective? Being able to show that, overlapping that with your own data as well as an LLM, RAG is really the best tool for that. Really don't recommend using fine tuning unless you have a large AI team already that's able to provide that context. But as we start thinking about Gemini 1.5 Pro, it has a 1 million token context window. And that's really where the architecture came from with RAG, is that the context windows were much smaller. But really, it's a game changer. It's really enabling the model to process vast amounts of data. So if you think about Gemini 1.0 Pro, it only had a token window of 32,000. Claude has 200,000, but Gemini 1.5 Pro has a 1 million context window. So if you think about that, that could ingest 1 hour of video. That can look at 11 hours of audio. It can look at 30,000 lines of code, like we talked about with AI agents being able to provide application-based support from a Gen AI perspective. 30,000 lines, you can make a really large application. 700,000 words, that's Lord of the Rings right there. That's a huge book. But being able to think about the long-term memory of this as well, as that context window gives that aspect. So as we start thinking about different modalities and different process and different complexities, that's really going to give you that ability to drive that forward and be able to look at that as window. So again, just kind of encapsulating this slide is the more context window that there is, the larger it is, the more that you can put into it, the more that's stored, theoretically reduces the need for you to augment it as much, but still want to be able to provide that with your own data and provide that forward thinking process. Well, we've covered a lot in the last 40 minutes or so. It's really easy to get started with your own data in LLMs. RAG makes it more accessible than ever. GCP tools, really make it easier than ever as well to get started. So if you think about some of the tools like Cloud Run and Data Canvas, you can use the Data Canvas Gemini feature like we showed in this webinar, but you also can do the same thing in Looker as well. So that's a really great way to get started. Vector databases, really are the way to get the best performance from a RAG perspective, and being able to drive that as well. So obviously we showed a relational data store, kind of use a RAG light or RAGless architecture. Really don't recommend that outside of POC and getting some of that adoption, but being able to drive that forward as well. And then lastly, it's better to have something that's 80% of the desired functionality than 100% and it's not used. And I've been a part of teams. I know some people on this call definitely have been part of that as well. But just getting something out the door and used and getting feedback from users and getting that excitable aspect of that is a really critical way just to get going. And, typically that's where the funding aspect comes from, is like, we can't ask for 7 figures and we'll have something done in 2 years. Being able to have something leveraged is going to really help you get better adoption for that as well. And then with that, we have Al as our slide here for Q&A.
Awesome.
Brandon,
Yeah,
I'll kick
awesome.
it over
Thank
to
you,
you for
Justin. A
Q&A.
lot of great insights. Looks like we've got some good questions coming in here. Do want to encourage everyone to upvote if you see a question in there that you're also thinking, so that we can prioritize, so we have time to get to the important ones or the ones that most people have questions around. So the first one I'm seeing, Justin, is, can we fine tune an LLM without any API key?
Without any API key. So the difficulty is probably not. You would have to train essentially a much more restricted LLM on your own data to begin to provide that context on a vector database or a BigQuery environment. You would essentially have to make that homebrew, which I wouldn't recommend, but you would have to use an API key, yeah.
Got it. We have another one here. I'm not sure if it's a question. I'll read it. It says, I have heard that the context window still misses a lot of the internal data in the middle, so it doesn't provide it in the responses.
Yeah, so obviously this is less than a month old, so there's a lot of things that are still happening. So, definitely think about this from, you're still going to need a RAG-based system to have the best results. So the context window, I think it's more of a, think about buying a piece of land. Like we did the apartment home and building custom island. Like you're essentially building a much larger plot of land to build what you want to build. I still think that there's a lot of mechanics of how that context window is going to be leveraged in an insightful way. But I've also read that as well, but I'm also very hopeful that that context window is going to really be a game changer, because, the biggest limitations from an LLM perspective is once that is, it's kind of a closed system, right? So like when ChatGPT, for example, first came out, it would literally say this has been trained on data until April of 2023 or 2022, being able to show that. So it's essentially kind of a closed box, right? So it's not accessed internet. One term we didn't talk about was called grounding. So part of that context window of the 1.5 million, context window is that it's allowing you to do the grounding on Google search itself. And I feel like that might be the most exciting feature of that announcement is being able to have those LLMs and that grounding based on Google search itself is going to be incredibly powerful.
Awesome. Thanks, Justin. Looks like we have one more question in there. Is there a project or GitHub that they can have access to try and replicate what you've shown here in the demos?
Um, Sorry, Brandon, can you say that question again?
Yep. Is there a project or GitHub that they can access to try and replicate what you've shown in the demos?
Yeah, so that demo that we showed was kind of meant to be shared. So what we'll do is we're going to take out our specific API virtual environment as far as the environmental variables that we connect to our applications. But absolutely, as part of this recording, want to be able to share that GitHub and allow you to build on that as well. So I think that's a pretty big component of like I personally hate webinars that everyone just shows 20 slides and they expect the Red Sea to part and everything's great. And being able to drive that with actual code as well as this recording once it's done, absolutely we'll be able to share that out.
Awesome. Looks like we have one more in here. So can an LLM help flush out data definitions or data policy? One of the biggest issues we have with our data is figuring out what each attribute actually means.
Yeah, so it actually could do a couple different ways. And Brandon, I think you'll like this based on the RFP conversations we've had, but it could do a variety of things. One, it can do feature engineering. So a lot of these LLMs now actually could do data analysis of saying what data is related to other data, but then it also can look at what metadata it can help it organize. So we were in a workshop a couple weeks ago, and they said that someone wrote a data governance plan of all the definitions and terms based on ingesting all of their relational data stores and PDFs. Not only was it able to create a concise document for them, but it actually showed inconsistencies in definition across other data sources that showed where things are need to be merged, right? So, a lot of times different teams have different definitions, and that's also why data governance is really hard, is because not all teams agree on it. We're all busy, we're all professionals trying to do the best job we can. But a lot of times that documentation slips with time because it's so far down on the totem pole. But then being able to use like RAG to be able to pull in those data stores and look at that retrieval method, but then also looking at an LLM can actually provide some of that insight of where there are inconsistencies. So absolutely, that's an incredible use case. Another use case of that is call center. So a lot of times that there's call center consistency and also limiting call center dependencies of saying we have our training documents that do these things, but we want to help de-escalate where a user would need to call a call center from an internal perspective as well. So being able to centralize that information, I think, is going to be one of the largest benefactors of some of this new technologies in the space right now.
Awesome. Thanks, Justin. We have one more in here. How do you explain the security aspects of building an isolated RAG to executives worried about security?
Yeah, so there's six components. One is really the network configuration side. So you're looking at things like virtual private cloud, having your private IP addresses and appropriate firewall rules. Looking at service controls. That's aspect number one. Aspect number two is looking at your access controls, your identity access management that I managed as well. Third is data encryption, being able to show that. Fourth is auditing and monitoring, looking at the tracking of the access and the resources. But really, the fifth and sixth is really the meat of this question. So the fifth is API exposures. So for example, looking at your RAG system or a Llama model or Gemini, whatever it ends up being able to understand what authorization and mechanisms, you can be able to get to lock that down with API keys and OAuth. But again, that ties into the virtual private cloud, that it's not actually leaving the four walls of your environment or your storage bucket. So then it's not actually saying copy paste a super sensitive financial spreadsheet and then it gets shared with the internet. That's really bad. And then 6 is really the data processing side. It's, really understanding how data is handled within a RAG system. If the retrieval component assesses external data resources, ensure that there are connections that are secure and that sensitive data is not inadvertently exposed. But being able to understand from an embeddings perspective, looking at the hierarchies to begin to retrieve the information. And if you do it right, an LLM response mechanism should just be pulling in the natural language response fields rather than the data itself. So then there's no exposure whatsoever from an environment. Good question. I prepared for that one.
Let's see, looks like we got another one coming in here. Oh, has AI changed protocols for storing and securing API keys?
Right now, no. I would say all of the tools within GCP specifically, obviously we've been pretty centric around that. But as far as how API keys are managed and maintained, that's really still the same. However, the security protocols of how those things are run are slightly different. So I mentioned Cloud Run as an example. That's really being able to kick off a RAG process, for example, and being able to pull that information. I would say the biggest thing from an API key perspective is when you want to do data refreshes. So, for example, if you have it closed off, you have to be on your own company's firewall to access this information. That's probably the best way to lock this down. But then also being to understand that the API keys, it's really going to follow those same architectures, secret keys and cloud secrets as well, is that's all stored in the same mechanism. I think GCP is really going for more of the Gemini, Llama. I have been very specific on Gemini, but like the nice thing about GCP is you can swap other open source. Llama 3 is coming out. I think they're in public beta. But being able to leverage that across all different infrastructure and making sure the security is there as well.
Thanks for that. Another one around compliance regimes. Have they caught up with LLM RAG data architectures yet? Not just explain to execs, but be able to put a safe label on it?
I would say no. I think that there's still a lot of misconception that I think part of what's happening right now in the next, I'll say 6 to 12 months, but we need to be able to provide everything I encapsulated, as fun, passionate data guys speak, into a lot more legalese, right? And being able to tie that into much more of a compliance and data governance framework that a lawyer understands really where that line is. Cause like the slide I showed from the RAG retrieval of your own data versus an LLM, and then there's that circular two icons. That's what a lawyer and a compliance team is going to care about. Okay, well, very clearly articulate what that overlap is and how that is. So I do know that there's a lot of contributing documents that are coming out, but I would say the answer is no, that I don't think that legal teams are fully onboarded with understanding where there are data exposures just due to the sheer overlap of some of these services currently.
Awesome. Thanks for that, Justin. Another question around providing the demos that you had created for them to practice in. I can say that we can reach out to set up some deeper dive demos, even some customized demos, and kind of work with you. So you'll get some information and some follow-up around how you can set that up. Anything to add to that, Justin?
Yeah, so the data canvas tool you can leverage now. So if you have a GCP environment and any BigQuery database, they've rebranded BigQuery as BigQuery Studio, and you could create a data canvas literally right now. And so that's free. That doesn't need us involved at all. As far as the actual GitHub, the front end application and some of the code I showed in Visual Studio, like we're happy to share that out and actually help you run it against your own data. Or we can start sharing some of the GitHub repos as well and kind of understand the use case. But that information is meant to run on your own data, which was the point of the webinar as well. So again, Data Canvas and Looker powered by Gemini, that's ready to go right now. And then some of the applications that we made, absolutely can train on your own data without any issue.
And we'll be reaching out, so you'll have some contact information. We can schedule some additional calls to help get you started, with some of those demo environments that are a little bit more personalized for your space.
Yeah, absolutely.
Do you currently see AI being leveraged for majority cost reduction or majority like revenue generation in its early days?
Yeah, so a lot of times that I'm, especially in, more of the helping clients understand this is that I'm a huge proponent of AI is not meant to replace workers. It's meant to augment and help with more efficiency. So really understanding where the industry is going is it's much more along the lines of we want to begin to take our users who aren't bogged down with internal process and doing documents. Let's free up those knowledge workers to provide that actual knowledge. And I think all of us can agree at one job or another we've done a lot of cog stamping, and we didn't get a lot of value from that. And I can think of jobs earlier in my career and thinking about where Gen AI could have automated some of those aspects, so I could have done a lot more of the analysis and actually provided some of that value. And you think about human understanding, what humans still are better than AI models are without there being general artificial intelligence, and that's a whole nother tinfoil hat conversation. But humans are best at conceptualizing or best at understanding connections that have that unbridled view of how we connect those pieces, and AI is a component that helps us understand those connections better to provide that strategy and value to our organizations. So I would say right now I'm seeing a lot more internal operational efficiency rather than new business development revenue generating. So like companies are like, well, what if we did this one process and sold that process to companies that we've mastered that? That's one aspect. It's a lot more around internal efficiency right now that we're seeing.
I think we have time for one more question if there's one out there. I'm not seeing it. Well, thanks again to Justin for his insightful presentation and to all of you for joining our webinar on how to train large language models with your own data. We hope you gained valuable knowledge about LLMs and the exciting possibilities they hold for your business. Here's what you can do next. You'll receive an email with a link to the webinar recording. Watch it, review it, share it, complete the short survey you'll receive. Let us know how we did. Visit the Nerdery website to learn more about our data and AI solutions and how we can help you implement custom LLMs for your specific needs. Feel free to reach out to us if you have any further questions about LLMs or Nerdery services. You can find our contact information on the website. Again, we appreciate your time and engagement today. We host regular webinars on cutting-edge topics, so be sure to stay tuned for our upcoming webinars, including, Justin mentioned it at the start of this, Intro to AI Agents on Tuesday, June 18th. Thank you once again, and have a wonderful day.
See ya.